let's listen to Buckminster Fuller talk about he's got a vector equilibrium model that he's playing with.
Is a completely unstable condition. That is, when we first had submarines, we used to fill the water ballast tanks so it was just at equilibrium. And then if anybody happened to just drop a monkey wrench over, it could throw the balance out and they would tend to nose over and get into a great deal of trouble. When we began flying, then we came to what we call the stall. Stall came to a point when at the equilibrium, at the stall, anything can happen, can go any kind of a spin. Nature abhors that equilibrium. She always, everything you and I know will always be one side or the other of the equilibrium. At any rate, this is the most expansive form of these vectors that I gave you. Now here's vector equilibrium. Can everybody see this all right? And I'm going to take this top face and move it lower towards the face on the floor. And this top triangle is not allowed to twist. It can only approach the triangle on the floor. Got two planes approaching each other. Understand? So this means this vertex will always be towards you here. And the vertex on the floor is towards me. So I'm going to do this. Suddenly, it's collapsed to where the square are changing. They become diamonds, then ridgepole diamonds. Now the distance between the vertexes is such that the line is exactly the same as the other vectors. Therefore, I put in 6 vectors there, and you have the icosahedron. This is the icosahedron. Vector equilibrium then comes down to the first stable form, which is the icosahedron. The vector equilibrium itself consisted of 8 tetrahedra, each of a volume of 1, 6 1/2 octahedra. A half octahedra is 2, so 6 times 2 is 12. 12 and 8 are 20. The vector equilibrium volume is 20. And so it now collapses correctly. I want to show that 20ness of the vector equilibrium gets tightened up into the icosahedron with another set of vectors. 6 more are introduced, or 1 more unit of quantum. Now I'm going to keep lowering that triangle towards the floor, not twisting at all. And now it suddenly contracts to become the octahedron. That's a very beautiful thing you watch. All vertexes approach common center at a common rate. There's absolutely symmetrical expansion. Comes by up here and now contracts the other way. But the axis in my hands never rotates. Only the equator is rotating. Now I can go, supposing this is rotating in space, this group of stars, there's a mass attraction pull of another set of stars, and one then, this is trying to turn, and then it restrains this. What happens when you do that would be then, I move this around, it forces it to contract. If it's being forced to contract that way, then, remember, notice it's rotating this way. This rotates more and plunges right through and becomes the tetrahedron. We've gone all the way from vector equilibrium, icosahedron, octahedron, vector equilibrium. The octahedron is double bonded, tetrahedron is quadruple bonded. Quadrivalent, we call it. This way diamonds are with respect to carbon. We have no point to break open. So the maximum space employed by unity is a vector equilibrium, but all the structures are within it. They're contracted form from the whole.
Okay. So there's a lot of stuff in there, which is...
Now notice that this can then tetrahedron, I had it plunge that through.
It can be difficult to follow him. It's difficult to follow him in writing. But you see the way that he's operating, and mostly what I wanted to show you is the relationship, that cube octahedron, and how it contains and encodes all of the Platonic solids that we've been talking about. And in different circumstances, different forces acting on it, it shows up in different ways and is very malleable and resilient in that way. And so he mentioned a couple things in there. One is the rotation around the center, right? As the two faces, which he said, these faces are not rotating, but as they approach each other, the center spins. And so that's the polarity that we talked about, right? So there's the center pole, and then things spin around that. Yeah, let's see. There's just, yeah, I just love him. He like, I want him to be my grandpa, he's just like such a cozy kind of guy, but he's also like a transcendental genius. So then as Dan wisely pointed out before, the vector equilibrium reminded him of the seed of life. And here we're going to watch a video.
Here we are at one of the world's oldest sacred sites, the Osirian Temple at Abydos, Egypt.
Very little writing is found in the Osirian Temple. However, there is one very significant piece of information in that temple. It is a very faint but clear and precise drawing. It's not etched into the rock, it's not carved, it's burnt into the atomic structure of the rock in some extraordinary way.
Nassim has decoded the Osirian symbol in 3 dimensions. Since our world is not two-dimensional, it makes sense that codes relaying information about our world also wouldn't be limited to flat designs. His 3-dimensional version of the Osirian symbol starts with the vector equilibrium, a perfectly balanced force field with 12 equal energy lines radiating out. They stabilize its center like the 12 spokes of a wheel. The primary pattern of balanced energy flow around this structure is the torus. Here we expand to the next larger scale with a total of 64 pyramids called tetrahedra. If we then put spheres in representing the toroidal energy field surrounding each of the pyramids, and then we drop away the pyramids, we end up with a matrix that is, amazingly, an exact overlay for the Osirian icon, a 3-dimensional model of the same pattern that was burned into the rock wall of the Egyptian temple thousands of years ago.
Why do you think there was 2 adjacent to each other?
Why do you think there were 2 adjacent to each other?
Because there's more than just one of us on this planet.
And I mean, the thing that comes to my mind is like, to get all 92 of the
The most difficult thing is
you need 2. We had a pair of nested platonic solids, right? And so there's something about the pair and the tension of duality that gives rise to all subsequent creation. And so that's my sense, is that it's
like human relationship.
Yeah, and human relationship.
A combination of multiple structures combined.
Yeah. So disclaimer on that is that clip comes from a movie called Thrive, which perhaps many of you have seen. I like a lot of what's in there. Can't fully vouch for everything, and especially what Parker Gamble and his partner have done since. Like, that initial movie was pretty brilliant, and then what they've done since, can't fully vouch for it. Use your own discernment, but there's a couple little things. I love Nassim Haramein's work. He's done a bunch of stuff. He has a movie called Black Hole, whole spelled like whole wheat, right? And a lot of his work is really exciting and promising, sort of cutting edge astrophysics. So I'm a big fan of Nassim Haramein. You make your own socio-political choices about who you listen to. Leave that aside for now.